Hello.
Yes, sir.
Yeah, I will just
Start.
I will just share the screen.
Akanksha, can you help me?
Is it coming full screen? Hello.
Sir. Yeah, it's coming in full screen, sir.
Full screen, everything is seen, right?
Yes, sir.
It's not cutting on any places.
No, I can read the bottom line is NCSC meet the scientist 17th date. That is the bottom line, and I can
Right.
see with the pictures on the both sides.
So I think it looks to be working fine. Okay, I think so. We can start now.
Okay. A very
Will we
good
start
evening.
like this, or you want to share it later?
No, sir. I'll introduce you first to our participants who have joined us, and then we'll hear you, sir.
No. What I'm telling is, you want me to be sharing it now itself or later?
Maybe, sir, after the introduction.
Okay, so stop sharing.
Thank you, sir. Thank you. So, a very good evening to our guest, Dr. Anil Bharadwaj, Director PRL, all the participants who have joined us on the NCSC virtual platform as well as on the YouTube channel. Very good evening to all of you. So I have the pleasure of introducing Dr. Bharadwaj today. So Dr. Anil Bharadwaj did his PhD from IIT BHU in 1992. He joined Indian Space Research Organization in 1993 as a scientist at the Space Physics Laboratory of the Vikram Sarabhai Space Center in Trivandrum. He became the head of the newly formed Planetary Science branch of SPL in August 2007 and was subsequently the director of SPL during February 2014 to February 2017. Currently, he is the director of Physical Research Laboratory, PRL, Ahmedabad, and he has worked at NASA Marshall Space Flight Center, USA for about 2 years as National Academy of Science Senior Research Associate during 2004-05. Dr. Bharadwaj initiated the research in planetary sciences at SPL and contributed to the development of planetary science activities in ISRO, Department of Space, and planning of the planetary missions of India. He was the principal investigator of the SARA experiment on the first Indian lunar mission, Chandrayaan-1, which has revolutionized our understanding on the interaction of solar wind and the moon through several new findings. His research in the field of solar X-ray astronomy finds place in several press releases by NASA and European Space Agency, ISRO Story of the Week, cover pages of the American and European journals, and American Geophysical Union journal highlights. Dr. Bharadwaj has over 130 refereed publications and several chapters in books, including a chapter in the Encyclopedia of the Solar System. Dr. Bharadwaj has supervised several PhDs as well as MTech and MPhil students as well as MSc students. So with such a beautiful and wonderful career spanning over so many years, I invite Sir for his talk and interaction with the child scientist of the country. Sir. Sir, you are muted. I can't hear you, sir.
Can you hear me now?
Yes, sir.
Okay, great. So thank you, Payal, for introducing myself to the audience and particularly to the children's of this Science Congress for the Children's. And I will be sharing my file and start talking about the Indian planetary missions, or
Sure, sir.
essentially talking about how India is doing exploration in the area of solar system. And I will take you to a journey to exploration of the different planets in our solar system, particularly the inner part of our solar system, which ISRO or India has achieved already, and what we plan to do in the future. I hope my screen is all visible to all of you.
Yes, sir. Yes, sir. It's visible.
Okay, great. So when we talk about myself, I am from Physical Science Laboratory, which is one of the oldest institute in India. And this institute was founded in 1947. And that is why it is called as the cradle of space science in India, because all the space science program actually started in PRL under the leadership of Dr. Vikram Sarabhai. PRL has 4 campuses, which you are seeing in the bottom of this picture. The main campus in Navarangpura in Ahmedabad. There's another campus in Ahmedabad in the Thaltej area, which is 5 kilometers away from the main campus. Then we have Udaipur Solar Observatory, which you are seeing here in the bottom, USO, which stands for Udaipur Solar Observatory. It is the middle of the Fateh Sagar Lake. So we have an observatory right in the middle of the lake. And then we have an observatory in Mount Abu, which is called as Mount Abu Telescope Observatory, which is an observatory to look into various astronomical objects in the sky, particularly in the night, whereas Udaipur Solar Observatory is meant to look at the sun, so they work in the daytime, whereas Mount Abu people work in the night time. So as I just mentioned that PRL is the brainchild of Dr. Sarabhai, whose birth centenary year we celebrated about 2 years back. And PRL now is 75 years old. So along with the Azadi Ka Amrit Mahotsav, when India is celebrating its 75 years of independence, PRL is also celebrating its 75 years of existence. And we are in the Platinum Jubilee year of PRL. And to do that, we are having a special colloquium series, which we call as PRL Ka Amrit Vyakhyan, which started last year on 4th of August. And so far we have 29 such Vyakhyans every Wednesday at 4 p.m. And one can log in into this YouTube channel and see all those Vyakhyans which has happened in the past and which are going to happen in the future. Now, talking about PRL, as I was just mentioning, that it started with the idea of having a space science laboratory. And Dr. Sarabhai all started this in his home, which is called Retreat, in 1947. And then in 1948, it moved to MG Science College. In 1950, we had the first council meeting, where you can see the gentleman standing is Professor S.S. Bhatnagar and R.S. Krishnan and Dr. Sarabhai and Homi Bhabha are all sitting in this audience. And in 1951, we had the first ozone measurement started in Mount Abu. So PRL, which got established in 1947, has its first foundation of its own building in the year 1952. And it was done by none other than Sir C.V. Raman, the Nobel laureate of India. And that is why, that is because Sarabhai used to treat Raman as his guru. So he called his guru for the foundation stone laying ceremony. And in 1954, Pandit Nehru, the then Prime Minister of India, actually inaugurated this building. So in the top right, you are seeing this building of PRL in 1954. And later on, a multi-story building in the back was came into function. And that is sometime in early 70s. And the bottom right picture is how you see PRL now, about a year back, last August 15th. So as I was just telling you, we have another campus in Ahmedabad, which is called the Thaltej campus, which is also housing many of the laboratories, and many of our scientists and academic faculties sits there at the campus. And then there are campus in Mount Abu, which is Infrared Telescope Observatory, and Udaipur Solar Observatory, where you're seeing the building of that, not inside the lake, but the observatory is inside the lake. The building is outside on the land. Now, when you look at this logo, which is actually the logo of PRL, you must be thinking, what is it, right? So I'm just going to explain you what it means. First of all, if you see the circle over here, I don't know whether you can see my cursor moving around. This circle with this cross in the center means it is a symbol of the earth. And another circle on the left side with a dot in the center is the symbol for the sun. And both the circle are encircled with another big circle, right? So what does it mean? If you translate this into words, it means PRL research encompasses the earth, the sun, emerged in the fields and radiations reaching from and to infinity, all that man's curiosity and intellect can reveal. So that is what the meaning of the logo of the PRL is, which in turn means that PRL is trying to understand the processes happening due to radiations coming from the sun, both particle and field, and it tries to understand what is happening in the deep core of the earth to the end of the universe. Now, if you look at what kind of scientific activities are being carried out in PRL, it consists of astronomy, astrophysics, solar physics, space atmosphere science, atomic molecular physics, theoretical physics, geosciences, and planetary sciences. And we have a very active program for students and postdoctoral fellows. These are basically students who have done their post-graduations, mostly in physics, and then they come for doing research. So PRL provides them 5 years of fellowship for completing their PhD degree. And after that, they become independent scientists. PRL also has postdoctoral fellows, that is those who have done their doctoral program, that is they have earned their PhDs, and they come from different other institutes in India to work in PRL for about 2 years. So basically our focus is to do research in the niche areas of all these 7 fields and internationally competitive research. Some of the names which you must be very familiar with, and that's why I'm telling you about them only. The top one in the middle, I think you can see Professor Abdul Kalam, who actually worked in PRL, and he was actually working with Dr. Sarabhai. And Dr. Sarabhai wanted to start the rocketry program, and that's why Dr. Kalam was sent to Tumba in Trivandrum in Kerala to start the rocketry program. Professor U.R. Rao, alumni of PRL, who did his PhD in PRL under Dr. Sarabhai, has been the chairman of ISRO and Secretary Department of Space. All of you must be aware about. And Dr. Kasturi Rangan, whose name is very familiar to most of the kids because he has written the new education policy of India and has been the Secretary Department of Space and Chairman ISRO, is also an alumni of PRL. He did his PhD in PRL. And of course, there are many others whom you may not be able to recognize, but they all are leading figures in the country and have been directors of various national institutes. Now, talking about the planetary missions in particular, I'll be talking about a little bit of a Chandrayaan-1 mission, then talking about the Mars mission. And this is all possible because India now has its own rocket program. We have a launch vehicle, which is launched from Sriharikota and Shar and takes the satellite into space. So we all started this activity from Tumba, as I was just mentioning that Dr. Kalam was sent by Sarabhai to go to Tumba to start the rocketry program. And we had the first launch on 21st of November of 1963. And there was a rocket which was flown, but the experiments or the payloads flown on this first rocket was developed in PRL, in Physical Sciences Laboratory. Then we had the satellite program. So Professor Rao was sent by Dr. Kalam, Dr. Sarabhai to Bangalore to start the satellite program. And that is how we had the first Indian satellite Aryabhatta launched in 1975, which also had experiments developed in PRL, that is Physical Sciences Laboratory. Subsequent to that, there have been many other missions, which was like SOS-C, C2, and they all contained experiments of X-ray astronomy and physics sciences, and many of the instruments were actually developed in PRL. But when we talk about the planetary exploration program, One can say that it all started with the Chandrayaan-1 mission. And Chandrayaan-1 mission, which you all know, was launched on 22nd of October of 2008. And after traveling for 16 days, on 8th of November 2008, we reached the moon. It has 11 experiments on board. 3 of these experiments were being flown for the first time for any planetary probing. And this picture, which you are seeing in the right side, contains the name of the experiments, which are expanded over here. I will not go into detail of that. But if you look at this picture, where you see each of this very clearly identified, and then the one which you are seeing here, the SARA, is the instrument where I was a principal scientist. So we had 2 subsystems of the SARA called SINA and SIM, and they were actually being flown for the first time to do ENA imaging on the moon. There are many science results which has come out from the Chandrayaan-1 mission, but the most important of them is discovery of water on the moon. Till that time, we are all thinking the moon is bone dry, but Chandrayaan-1 mission told that no, there is ample water on the moon. It is there on the subsurface, on the surface, and in the exosphere. There are more than 180 scientific publications which has come out from this mission, and which also includes talking about validating the lunar magma hypothesis, essentially trying to say how the moon got formed. Many magnetosphere discovered on the moon, many craters, volcanic vents, and many rallies, which in turn suggest that in the future, when the human exploration starts in a big way on the moon, one can use this kind of lava tubes or rallies for human settlement. There are many science results which has come out. I just mentioned about 180 of them or so, and some of them have actually made the cover page of international journals like Science or the Geophysical Letters. Now, talking about how does the Earth look like from moon, this is the picture which was taken on 22nd of July of 2009, and you see here the beautiful Earth seen by the Chandrayaan-1 when it is orbiting around the. Now, moving on to the Mars mission, or Indian Mom to Mars, that is Mars Orbiter Mission of India. And we all say that Indian Mom is around Mars. This mission is a highly successful mission in terms of technological demonstration because it has already completed 7 years of its existence around Mars. We had the launch on 5th of November of 2013. We got inserted into Martian orbit on September 24th of 2014. That is after 10 months of travel from Earth to Mars. And since then, this MOM mission is orbiting around the Mars. It has completed more than 7 years, though the lifetime of this mission was just 6 months. And this has made India the first country in the world to have the successful insertion of an orbiter around the Mars in the first attempt. So this is a big technological feat for the country, that India is the first country in the world to have the successful insertion of an orbiter around the Mars. This is all showing the timeline of how we were launched, then we went around the Earth to gain the velocity so that we can escape the Mother Earth. And then we started into an orbit, heliocentric orbit around the Sun, and reached to a location where the Mars is, and then we got inserted around the Mars. So this is a huge technological challenge which comes up when a mission is of this kind and this magnitude is taken up, and India was able to do it very successfully. There are 5 experiments on board, and the bottom one which you see over here, the MENCA, or the Mars Exospheric Neutral Combustion Analyzer, is the instrument where I am the PI. And people say that we have sent MENCA to the Mars, so thinking that probably Rishi Vishishta or Rishi Vishamitra is there. There are other payloads or the other experiments which have been developed by various other institutes of ISRO or Department of Space. And the total mass of this is only 13 kg, whereas the whole spacecraft mass is 1300 kg. So these are the 5 experiments which are in orbit around Mars, and the MOM mission is actively working. These are some of the images which has come out from the Mars mission. This is the full disk image of the Mars. One can see very clearly the superficial features on the surface of Mars, or you can see it how does it changes its seasons in terms of its visibility and superficial features. The top one is the North Pole, the bottom is the South. We are seeing also the ice getting formed on the poles and the cloud formation in the polar regions. And here you can see Phobos, which is one of the small satellite of the Mars, moving in front of Mars. And that is what is also a very important and a beautiful picture which shows how the small satellites are moving around Mars. This is a very important feature on the Mars, which is called as Valles of Marineris. It is the biggest canyon in our solar system, bigger than the Grand Canyon in USA. And currently you are seeing it completely filled with clouds and dust. So you see here, this all features are clouds which are elevated in the atmosphere, and you are seeing the shadow falling over the surface. And there are excellent science results which have come from the instrument called MENCA, where I am the PI. And the most important of them is how does the neutral atmosphere changes as you go up in the atmosphere. So this is a profile generated for the first time in the evening time atmosphere, which made the ISRO story the week also, because we told that during the evening time, a CO2 dominated atmosphere of the Mars changes to an oxygen dominated atmosphere somewhere around 250 to 260 kilometers above the surface of the Mars. We have also found the suprathermal argon, or you can say the hot argon. So this is a discovery which has been done by Mars mission of India, where we are now able to show that there are hot argon atoms in the exosphere of Mars, which can allow the atmosphere to easily escape. Because if you have hotter species in the top of the atmosphere, then they will have sufficient energy to escape the planet. And that has implications for the energy budget and escape processes on the Mars. So how the Mars is losing its atmosphere can be now recalculated based on this new science results. We are also seeing clouds getting formed around the mountains, particularly in the leeward side. So here you are seeing a big mountain which is called as Olympus Mons, which is the highest mountain in our solar system. And the white color which you're seeing on the leeward side is nothing but the clouds. We have also seen Deimos, which is another satellite of Mars. So Mars has only two satellites, Phobos and Deimos, and Deimos is smaller than the Phobos. And for the first time, we are able to see completely all around the Deimos using the Mars mission. So when the Mars mission became very famous, one of my colleagues from US sent me this, picture and says that the Mars mission of India called MOM has become very famous, and it has come on the Coke diet. So you are seeing here a Coke diet with the MOM written over it. And in fact, the Google celebrated with a doodle 1 month later on 24th of October 2014, because we have the successful insertion on September 24th. And ISRO, Amul, which all must be aware about, they make a lot of milk products. So they celebrated this success by writing that ISRO's cow Amul, ye cheez badi hai mast Mars. So that is how the country was all celebrating. And National Geographic magazine has put the images taken by the Mars orbital mission of India on its cover page. And government of India, realizing this technological feat, has put the Mangalyaan on the back of the 2000 rupees note. So I hope most of the children must have noticed that at the back of 2000 rupees note, we have the Mangalyaan. Those who have not noticed it should ask their parents to provide them 2000 rupees note so that they can see it. Now let me talk a little bit about Chandrayaan-2 mission. Chandrayaan-2 mission is a much more complex and complicated mission than the Chandrayaan-1 mission, essentially because Chandrayaan-2 mission had not only the orbiter, but also the Vikram lander and the rover, Pragyan. And this was a soft landing for the lander, and then the rover which is sitting inside would come out and move onto the lunar surface. And we all know what happened on early morning of 7th of September of 2019. The lander could not land as was desired, but the orbiter is working around the moon. It is providing us excellent quality of data, and I will show something about that. So when we had the launch of Chandrayaan-2, which was in its orbit around the Earth, we all went around the Earth to gain velocity so that we can move from Earth to Moon. And then we got inserted into elliptical orbit, and then finally went into 100-kilometer circular orbit. And then we had the descent of the lander. So there are 8 experiments on board on the orbiter, which are working very well and providing excellent quality of the science data. I will not go into detail of this except to tell you that they are providing us information about the surface, surfacial features, distribution of various minerals and water, elemental composition of the lunar surface, and also talking about not just the surface but beneath the surface using the LNS band SAR instrument, as well as talking about the very tenuous atmosphere which you call the lunar exosphere and the gases present in the lunar exosphere. There were 3 experiments on the lander and 2 on the rover, but now this is going to go into the Chandrayaan-3 mission, which India is planning to launch this year. So these are some of the new information which has come out from the Chandrayaan-2 mission, where the terrain mapping camera is providing us information about the digital elevation maps or DEMS, ortho images, and how does the surface looks like from 3 different angles. And we had an excellent picture of the Sarabhai crater. So we have a crater on the moon named after Dr. Sarabhai. And this crater is on the near side of the moon. So if you have a good small telescope, you can actually see the Sarabhai crater because it is at 24.7 degree north and 21 degree east. So from the Earth, when the moon is completely sunlit, that is around the new moon, you can very clearly see the Sarabhai crater. This is how it looks like in the full glow. It is a crater of about 8-kilometer diameter and about 1.7-kilometer deep. There are many other information which is coming, like for example, this one called Lindbergh crater. And Lindbergh's crater is a 3D view of this is shown over here. But you can very clearly see also that in addition to big craters, there are very small craters also. And craters of all possible dimensions are there. And even on the walls of this crater itself, you have many craters. So actually, moon is full of craters. Craters inside craters, crater outside craters, craters of centimeters to meters to kilometers to tens of kilometers to thousands of kilometers. And the very big craters of more than 1,000 kilometers are called as basins. This is image coming from the dual frequency SAR instrument or synthetic aperture radar instrument. And this is an image which is not of the surface but beneath the surface. So this is a technology which provides us information of what is happening beneath the surface, and using a instrument called synthetic aperture radar or SAR at dual frequency mode, you can actually get information about craters which is buried inside the surface. And also it provides information about the water distribution or the ice distribution beneath the surface. Using the OHRC, which is an optical high resolution camera, we are now able to see features which are sub-meter size on the surface of the moon. So this is the highest possible resolution which is available using the Chandrayaan-2 instruments. And you can see here, small size boulders of 1 meter height and even craters of very small dimensions of less than a meter is now easily visible to scientists. We have an instrument on the Chandrayaan-2 which is developed within PRL called Solar X-ray Monitor, and this is actually the highest sensitive instrument ever flown to study the sun, because we are interested to what is coming out of the sun and impacting the moon, and therefore we are interested to look at what is coming out on the sun in 1 to 15 keV band, which is called X-rays. So this instrument provides a spectrum of that in 1 to 15 keV band every 1 second. And this is very sensitive compared to the GOES instrument, which is from NASA. And one can very clearly see that we get almost like 2 order of magnitude better sensitivity on this XSM instrument on Chandrayaan-2. These are some of the science results which has come out, but the most important part here is that now we are able to see small flares, which we call as micro flares or sub-A class flares. And very large number of them is actually happening on the sun, which we were never knowing. But using this instrument on the Chandrayaan-2, we are able to now know that these kind of micro flares are happening. Number one. Number two, they are happening in very large number, and that too during a period of 2019-20, which is the deepest solar minima of a century, let's say. So during last 100 years, we are seeing the deepest solar minima, and during that time also, we are seeing this micro flares happening in the sun. So this is a new revelation, which is changing our thinking about how the 1 million degree corona is getting heated up, and it could be probably that these kind of flares are actually pumping the energy into the corona. So that's how this science results made a lot of media hype, and they were all covered with various media and both TV and print media. There's an instrument on the Chandrayaan-2 called CHASE, which is talking about argon-40 in the exosphere, essentially because argon-40 is a inert gas like argon, and one can actually get a distribution of this around the moon to infer what is happening with respect to day and night. So what you're seeing over here is across the moon from morning, which is or somewhere here, which you call as 270 degree or 6 o'clock in the morning, then daytime, then evening, then sunset, and then night. So around as you go, as the Chandrayaan is 2 is going around the moon, we are able to see how the argon is distributed from day to night. And the beauty of this is that argon is a non-condensable gas, so it changes its amount in the exosphere of the moon from day to night. And this variability is now known at mid-latitude and high latitude for the first time. What next? What we are planning to do in the next coming years? We are now talking about Aditya L1 mission, which is a mission to study the sun, but it is not going to go to the sun, it is going to an L1 point. And L1 point is a point between sun and earth. You will see over here in this one, yes. So the sun is in the center, and this is the light blue is earth, and L1 point is on the sun-earth line, about 1% of the distance from earth and 99% distance away from sun. Now the beauty of this point is that this L1 point moves as the earth is going around the sun, so that you get a completely 24/7 coverage of the sun, because it is not going around the earth, right? And that's why we want to put to a place called L1 so that we see continuously the sun. Now this mission is going to carry 7 experiments, and it will look at the sun in the visible, in ultraviolet, and in soft and hard X-rays. But it will also measure particles which is coming out from the sun using an instrument called PAPA and Aspects. And the Aspects is the instrument which is developed in PRL and Physical Research Laboratory. And this is going to be one of the most exhaustive instrument ever flown to study the solar wind, because it is not only looking at the particles coming from the sun, but it is also looking at the other directions, not only just the sunward directions, to look at how the charged particles around the sun is influencing the planet Earth. And that's why this mission called Aditya. Aditya means sun, right? That's why it is called Aditya, and L1 is the position where it is going to be stationed. And it will take about 3 months for it to move from Earth to L1 point. So after launch, which is likely to happen this year, this mission will go into a halo orbit at L1, and it will provide a lot of new information about the sun. In future, we are talking about going again to Mars. That is the MOM-2 mission, and also studying the Venus. Venus, in fact, is a very interesting planet in our solar system, because it has similarity to Mars in terms of composition. It is also dominated by carbon dioxide. It is similar to size as Earth, so it has similarity to the Earth in terms of its size. But the surface of Venus is very hot. It is something like 800 Kelvin, or you can say 700 degrees centigrade. So it's very hot at the surface of Venus, and the surface pressure is 90 bar. You can say almost like 100 times more than the surface pressure on the Earth. So that means the Venus surface is very hostile. It's very difficult to survive on the surface of Venus. But when you go up something like 40 or 50 kilometers, you have clouds around this Venus, which you are actually seeing in this picture also. That this all structures which you are seeing is nothing but not the surface but the clouds, because you can't see the surface of Venus in the visible. It is all full of clouds, and that's why these clouds reflect light, and that's why Venus is bright. And these clouds are made of sulfuric acids, and they are at an altitude of 40 to 60 kilometers. And they go around the whole Venus, and they are completely engulfing the whole Venus. So at that altitude of the clouds, the pressure and the temperature is very benign. It is very same as the surface of the Earth. So that means the clouds of the Venus could be a place where life also can exist. And that's why people are now talking about exploring Venus, not just because Venus is very different than any other planet in the solar system, but also that Venus could harbor life in its clouds. So India is also planning to look at this Venus in much more detail, and we are planning to have a mission to Venus, where we will look at the atmosphere of the Venus, the clouds of the Venus, and how does the Venus interacts with its solar wind and solar radiation which comes towards it, and to get more information about the Venus which is not known, particularly because Venus is such a hostile place in terms of its surface that very less missions have been attempted at it, which is quite few compared to what has happened for the Mars, because many people are talking about now going towards the Mars in terms of not just robotic missions but also human landing on Mars. So India is also gearing up for this kind of exploration. But once we take it up, we are also thinking about not just talking about Mars and Venus, but we are also thinking about studying asteroids, comets, and other small bodies in the inner part of the solar system. And once we mature our technologies, we can start thinking about going to the outer part of the solar system. So with this, I would like to thank you all, but I will tell you that when you're talking about the planet in our solar system, PRL, that is Physical Research Laboratory, has discovered exoplanet, which is not in our solar system but other solar system. And this has been done by scientists of PRL using an instrument called PARAS, which is developed by the PRL scientists, and 1.2 meter telescope at Mount Abu. So I was mentioning about the Mount Abu Observatory, which houses this 1.2 meter telescope, and using that we have discovered the sub-Saturn size exoplanet, which takes 20 days to go around its star, and it is almost like 27 times the Earth mass and 6 times the radius of the Earth. So this is a new discovery which has been made. There are another exoplanet which has been recently discovered again. And this first exoplanet from India being discovered has been hailed by our Prime Minister also. And he wrote on 3rd of July of 2018, writing that we are immensely proud of our scientists who created history by discovering a sub-Saturn size planet 600 light years away from the Earth. Congratulations to them. The discovery put India among select countries. So this is the tweet of our Prime Minister Narendra Modi. And now we are coming up with a big telescope at the same site, which is a 2.5 meter telescope you see over here in this building. And this is going to enhance our capability almost by 1 order of magnitude because of high sensitivity of this instrument, large aperture, and the better electronics. So very soon you will be able to see much more scientific results coming out from both this telescope at Mount Abu. And those of you who are interested to visit are most welcome to come to Mount Abu and have a feel of how this telescope looks like and how scientists work there. So with this, I would like to thank you all for listening patiently, and I can take up any questions which are there. Thank you. Thank you very much.
Thank you so much, sir. Thank you indeed. It was very interesting and very nice to hear about the various activities and the mega explorations that have been carried out uh, by our Indian scientists. It was indeed a wonderful feat. So what will be the process if somebody wants to visit these observatories, and what would be the right time to visit them? Like in Udaipur, we see that it is like the monsoon time, it is usually kept closed. So, what would be the right time for students to visit?
Okay, that's a good question. So which season should be the best to visit, right? Is what your question is.
Yeah.
Monsoon season is certainly not good season because monsoon we close the observatories more particularly because of issues with respect to water coming
Yes.
inside the observatories as well as the high humidity.
Hmm.
Humidity is not a good, it's an enemy for astronomers. So we close the observatory because of high humidity and of course because of rains and winds. The best season is winter, sometime October or late October, November, you can say. November to March is a good period for visiting the observatories. And to do that, you can write to the observatory in charge, which is available on the website, or you can write to director, that is myself, uh, expressing the number of students who are interested to visit, if it is from a school or a college, and who is going to accompany them, because these are guarded observatories, so you have to get permissions to enter them. But once that all formalities are completed, you can go there and visit. And if you wish to see by yourself, in Udaipur, it has to be daytime, and in Mount Abu, it has to be nighttime. But daytime, you can go to the Mount Abu and see the place and see the observatory and how things are and how big the telescopes are and how does they work. And but if you want to really get a feel of that, then you have to be in the evening, something like 7 or 8, where you can see some objects in the sky also.
Okay, thank you so much, sir. So basically, like students usually think it's so cool to work in a research institute and are very fascinated by the scientists. So how cool it is to work in a research institute?
Oh, it's very cool. But how cool is cool? It's not the temperature, actually. Okay. Scientists have to really toil, whether it is deep winter or deep summer. Uh, it is not just observatories, which I was just mentioning about. When you make observations of the sun, it has to be in the daytime, so you have to look at the sky using the telescopes. But if you go to Mount Abu, even a deep winter, which where temperatures can be freezing close to zero, and but scientists are busy making observations. So it is not at all very cool in that sense, but it is very cool in the sense of interest and excitement which it brings. But not only that, we make observations, which I just mentioned about, and you're talking it, but we have scientists who go into the fields to collect data, particularly the geoscientists. Okay, they go on ship cruises, they go to mountains, they go to valleys, lakes, rivers, deserts, islands, caves, and they collect sample from there and bring it to the lab for doing analysis. And they find out that how old this is, how does this area came about, what it is telling about the history of that location, or about the India, or about the planet itself. So there are scientists who are working in different areas. There are people who are working in planetary exploration, for example, working on the Chandrayaan-1 mission, Mangalyaan, Chandrayaan-2, Aditya L1, or upcoming missions like to Venus or to Mars. Or there are scientists who are looking at processes is uh, which is called Big Bang, or how the whole universe came into existence. What are the particles which actually would have formed first when the whole universe got formed, and how it is now. So looking at the the model of the universe. Or there are scientists who are looking at processes which is happening at ultra fast time scale, something like femtosecond or attosecond, or lasers, light, and how we can play with the light. Can we divide a photon into two? Can we use this photon for doing quantum communication? So there are scientists who are working in quantum communication in PRL. They are developing new methods to do entangled photon source, which is basically the heart of the quantum communication. So there are people who are and scientists and faculties who are working very different areas, and that's what I was talking about. We have people working right from the core of the earth to the end of the universe, and it is very cool in some sense because we all get so much excited to find new things, but of course it is very toily also. So you have to spend a lot of time in collecting the data or doing the analysis, understanding it, and then telling others by writing publications or published papers.
True, sir. Sir, we have the space and atmospheric sciences divisions, and we see that they are studying the Earth's atmosphere. So this has been through so many years. What were the observations from, say, like the climate change perspective over the years? How has the observations evolved in that context?
Yes, that's a good question because I did not dwell with that more into detail. So we have a group in PRL who has been working since the existence of PRL. And it is precisely because the first director of PRL was Professor Ramanathan, K.R. Ramanathan, and he
Yes.
was a renowned atmospheric scientist. So along with Sarabhai, who was basically a space scientist, or you can say cosmic ray physicist, Ramanathan was an atmo scientist. And that's how these two fields started first in PRL. And PRL has a very long legacy in terms of studying the processes and what you call the composition of the atmosphere, aerosols, the clouds, the dust, the trace gases, and things like that. And as I was just mentioning that in 1951 itself, PRL has an observatory in Mount Abu to study ozone. Okay? And you must have heard about ozone hole and things like that, and this chlorides which actually destroys ozone, so it creates holes. So in PRL, what we do is that we study these different gases, trace gases particularly, like carbon dioxide, carbon monoxide, sulfur dioxide, nitric oxide, and things like that, and also volatile organic compounds. So which talks about total carbon and the carbon in different forms. Okay? And if you can measure that at a very large time scales, like 20 year, 30 year down the line, then you can talk about changes which you call as climatic changes. So one has to consistently keep on measuring. Okay, so measurement is the key, and that has to be also consistent with respect to what you have been doing 20 years, 30 years down the line. And you have to recalibrate your instrument to see that whenever there is a change in instrument, it should be a consistent data set. Now, using that, one can talk about whether it's a change in the temperatures, whether it's a change in the composition, whether we are seeing it implications for humans, both in terms of the visibility as well as in terms of the health of the human beings. So this kind of studies has been carried out in PRL for the last several decades, and there are very many science results which has come out. I'm not going to summarize them because it will take a little while, but one can visit the website of PRL, and there are annual reports which are kept online. One can go through that, or the publications which is also there on. So you'll be able to understand that. But bottom line is that there are implications for climatic change which is happening, and PRL is contributing in it in a big way.
Thank you, sir. If a student wants to pursue career in fundamental physics, your guidance to those students, how should they approach and prepare themselves for the future?
I should say not fundamental physics, but space sciences. Okay, because PRL is largely dominated by work carried out on the planet Earth and in space. And the way to do is that you have to do well in your schools and then in your college. You can take any subject, whether it is physics, chemistry, or maths, and excel in that. As I just mentioned, that we take students for doing research, and we take students who are from chemistry background or physics background or geophysics background or geology background. Largely, we are interested in physics background students because once you have done MSc Physics, you can be molded, I should say, okay, molded into any type of specialization. And in addition to this, if you talk about ISRO in general or Department of Space, they need people from all possible branches of science. You name any science or engineering field, the people are required from that field. Whether it's electrical engineering, mechanical engineering, chemical engineering, metallurgy, material science, physics, chemistry, maths, computer science, electronics, electrical, and now aerospace engineering, and now space biology, because we are talking about sending humans to space, like through a Gaganyan mission or human space program. So people of all possible science, including medical and biology, are required. And that's how, if you do excel in your studies at school level and at college level, whether it's a BTech, MTech, or even MBBS and or BSc, MSc, you can join Department of Space or ISRO.
Thank you, sir. One question that mostly we ask to scientists is that what fascinated you, or what was the inspiration for you to take up this space science as career? Your inspiration, sir, and your experience, or maybe some incidents that motivated you to take up this field.
Actually, science is always inspiring and exciting, but it depends upon which area one chooses. I was fascinated because in my childhood, when I used to look up in the sky, we used to see stars and moon. And moon, of course, is the biggest object in the night sky. And in the daytime, it is the sun, which is not so cool to look at. So one can look at the moon in the night. And that was my first fascination, to look in the night sky, to look at the moon, and to see the different phases of the moon, with its moon going around the earth and taking about 27 days. And you see the full moon, and then you see the moon gradually waning, and then you see the new moon. So you essentially don't see any, right? And particularly in the new moon time, you are able to see the sky much better because there's not much light in the sky because of moon. And you can also see sometimes, if you are capable enough in terms of getting a dark sky, a lot of stars. So that is how my fascination started, and I started thinking about working in this area. But after doing my MSc in physics, I was driven by the two missions which was happening around that time. One was the Voyager mission, which was sent by NASA to study the outer planet in our solar system, particularly Jupiter, Saturn, Uranus, and Neptune. And the second was the appearance of comet Halley. Comet, is are very small objects in the solar system, but as they come close to the sun, they are basically watery bodies, so a lot of sublimation happens, and then they grow up into a huge coma. So this was 1986 when Comet Halley came close to the inner part of solar system. It was visible in night sky after 75 years. And that really fascinated me, that what are these comets and why they move it in this orbit, and what does they contain and things like that. And that was a time when and the world was looking at this comet Halley in a big way. There were 6 scientific missions from European Space Agency, from NASA, and from Japanese Space Agency, including from Russia, to look at this comet Halley in a big way and to explore it. And that was a turning point for me that, oh, I should study this outer planets and comets. And that's how I came into the space sciences. And then slowly I started looking into how India can actually develop its own space programs in terms of exploration. And that's how I got involved into the Chandrayaan-1 mission right from the beginning, and then Mangalyaan and Chandrayaan-2, and so on and so forth. So it is all, the excitement which you get for by doing this kind of science, and the interest which is created within to do that kind of science.
True, sir. Sir, one last question is on Gaganyan, the role of PRL, or what role will PRL have in the Gaganyan mission?
Gaganyan mission is essentially a mission where our interest is to send humans to space, and the idea is that they just don't go to space, but they do some science there also. So in the initial stages, it will be just human survival in space, but the next should be that humans have to do some science. And as you know, the forte of PRL is doing science. So our contribution to that mission would be that once humans start going to space, what science they will do, what kind of science is not possible on the Earth, which can be done in space, is what PRL will be contributing.
Okay, thank you so much, sir. It was really a very wonderful and interesting session with you. And I hope all the students who have joined us in the virtual platform and YouTube must have enjoyed this session and will definitely be inspired by your talk. Thank you so much for sparing your time and joining with us, and for the nice, wonderful slides. Thank you so much, sir, and wish you have a good day, sir.
Thank you. Thank you so much. And thanks to all the children who must be listening to this. And if you have any questions, you can write to me with respect to not only your careers, but also with respect to your interest and the excitement which you have for your future. Thank you. Thank you very much.
Thank you so much, sir. Thank you. So we end the session here, sir.
Okay. Thank you. Take care. Bye-bye.
Thank you, sir.